A 16S2 LCD, liquid crystal display, is a type of alphanumeric display module that can display 16 characters per line on 2 lines, making it ideal for displaying simple text and basic graphical. You can find these type of LCDs either with header pins soldered to them or without them. This type of display is an invaluable asset for our current project and can be effectively utilized across a wide range of future projects. For example, you can use it to print the texts to it instead of the Arduino serial monitor, or you can make a goofy face of any type. Now, if you're eager to learn how to use this LCD, follow along with me. Like always, let's start by assembling our circuit. As you can see, this display has 16 pins, and I'll explain each one briefly and fast. The GND pin is a pin that should be connected to the ground, GND, of your circuit. The VDD pin is your power supply. This pin should be connected to the 5V power supply of your circuit. Our next pin is VO. This pin controls the contrast of the LCD. You can connect it to a potentiometer, or in your case, a PWM pin from the Arduino to adjust the contrast dynamically. The next pin is RS, or Register Select. This pin determines whether the data is being sent to the command register or the data register. Continuously, we have the RW, or Read-Write pin. This pin determines the mode of operation. When RW is equal to 0, the LCD is in write mode, and when RW is equal to 1, the LCD is in read mode. As our next pin, we have the E pin, or basically the enable pin. This pin is used to enable the display. A high to low pulse on this pin will latch the data into the LCD. The next pins are the D0 to D7 pins, which are the data pins. These pins are used to send data to the LCD. In 8-bit mode, all 8 pins are used. In 4-bit mode, only D4, D7 are used, which saves I/O pins on your Arduino. As the last 2 pins, we have BLA and BLK. The BLA, or backlight anode, is the anode plus of the backlight LED. It is usually connected to a current limiting resistor and then to 5-volt pin. Tendency. The BLK, or backlight cathode, is the pin that is the cathode negative of the backlight LED. It is usually connected to GND. Now that you understand the function of each pin and where to connect them, let's continue. Connect the LCD to your breadboard first, and then you can follow along with me when I'm wiring up everything. Connect a 5-volt and GND universal ground, and then start to connect the 5-volt and ground wires of your LCD too. For this project, I'll use the pins 4, 5, 6, 7, 8, and 9. But you can choose any pins on your Arduino that you wish. I'm going to use a potentiometer to adjust the contrast of our LCD. Also, I'll use an ultrasonic sensor to measure the distance and printing it on the LCD. Now let's jump into the coding part for this circuit. Open up the Arduino IDE, and the first thing that you are going to do is to include the liquid crystal library. Then you can make the trigger and echo variables for the ultrasonic. You can also check out the previous videos in this series if you want to get familiar with the functionality of the ultrasonic sensor. Now we will configure the LCD pins. And after that, we need to make an object of our liquid crystal to be able to use it later. We will use the method LCD_begin to initialize the LCD, and we will pass the values 16 and 2 to it. After that, we need to set our cursor to the beginning point. As you know, we can choose to put the cursor anywhere in 16 colons and 2 rows. Next, we will go on with setting up the ultrasonic pins, which are the trigger and echo. Set the trigger as output and the echo as input. If you want to use the serial monitor as well, you have to initialize it first. Now I'll speed up the things a little bit since we already covered them in the previous chapters. You can also find the source codes of these projects on my GitHub page. In the next step, we are going to get the distance from an object and make some decisions according to the distance of our object, and we will print the results on the LCD. For example, if the distance of the object is closer than 10 centimeters, we will print an angry face on the LCD. Also, I'll print the distance to the object as well. You can see that I changed the cursor pointer as well. It is because I don't want to get my other print messages mixed up with the first one. Also, to be able to see the result printed on LCD, don't forget to make a small delay. In here, I will only use 2 options to switch between states of LCD, but you can choose as many options as you want for your projects. At the end of your code, do not forget to clear the LCD screen so you can keep it neat and clean for next iteration of loop. You can do that by using a method called clear, which clears everything from LCD screen. Now everything is set. Let's run and see our results. Now in here, as you can see, as we come nearer to the sensor, the states will change on the LCD. If you liked this video, please like and subscribe for further videos.